Okay, so I'm gonna put together a video for the find solutions to a systems of equations assignment, the first assignment. You have 2 assignments on that one. This is the first one. So this will be slide 1. And remember, I'm not gonna always do the exact problems. I'm gonna do a sample. So they give you, on this first one, they give you 2 equations, and it says, identify any solutions to the system given below. So they give you 2 equations, and then they want you to check solutions that they have listed below. So there's our 2 equations, the 2 that I'm gonna do, and then we're gonna check solution 1, 2, 3, 5, 4, 1. So all you do is, remember, these are ordered pairs, they're x's and y's. So you're gonna substitute them in to each equation. So I'm gonna use 1 and 2 first. So 1 plus 2, well, does 1 plus 2 equal 5 for this first one? No, it equals 3. So we can already eliminate that one. That one's not a solution. The next one is 3 and 5. So 3 plus 5 in our first equation. Well, again, 3 plus 5 is 8. You can eliminate that. Doesn't equal. Last one, 4 plus 1 is 5. So we know that one works. Then we got to do the next one. So we're going to do 9 times 1, negative 9 times 1 equals 15 minus 6 times 4. So then that's negative 9. 15 minus, that would be 24. And then negative 9 equals negative 9. So that one is a solution. So I think you have 4 on there that you have to check. So you'll just check, and whichever one's equal both equations, they have to equal out in both equations. That is a solution to that equation. That was slide 1. All right, slide 2. So slide 2 gives you 2 inequalities that they want you to check. So again, they're going to give you some ordered pairs. So I'm going to do 3. So again, we're just checking, is the inequality going to work? Are they going to work with these ordered pairs? So again, you just substitute in. Start with your first ordered pair. Substitute in. So now it's 2 times 1 is 2 plus 5 is 7. And then you just, these are different because they're not equations. So you just say, is 7 greater than or equal to 6? Yes. So that one worked so far. So now we're going to do 1 plus 5. Whoops. So is 1 plus 5 less than or equal to 6? Yes, because less than or equal. So this one works. So the next one, 2 and 3. So 2 times 2 plus 3 greater than or equal to 6. So that's 4 plus 3, which is 7, and that works. So now let's try this one. 2 plus 3 less than or equal to 5. Well, 5 less than or equal to 5. Or, I'm sorry, 6. I'm going to change that. 5. Is 2 plus 3 less than or equal to 5? Yeah, 5 is less than. Or to 6, sorry. I keep saying 5. 5 is less than or equal to 6, so that one works. So this one's another solution. Last one. This time, 0 and 2. So 2 times 0 plus 2. Is that greater than or equal to 6? Well, that's 0. Is 2 greater than or equal to negative 6? Nope. So this one is eliminated. That one is not a solution to those inequalities, that system. And they're called, by the way, they're called systems of equations because there's more than one. So it's a system. All right, so that's slide 1 and 2. So now we're going to do slide 3. Now 3, I want to talk about for a minute. When you did the instructions, there was a lady who did a slide 6 out of the 13. It was 6 out of 13 on the instructions. That's where you can find this information. But she talked about how if you have 2 equations and your slopes, like once you put your equations in slope-intercept form, once your slopes are the same, so say I have two equations and I put them in slope-intercept form, and I look at my slopes, and I think on her slide, maybe she graphed them even. She was showing the graph. So this one is, I need to change that to 5. Sorry about that. Okay, so this is an example of two lines that have the same slope. These are in slope-intercept form. So remember slope-intercept form, y equals mx plus b. So whatever's where m is, that's the slope. So if your slopes are the same, but your y-intercepts are different, that's why I had to change that one to a 5, because those have to be different, then that means these are parallel lines. If you were to graph them, they would be parallel lines, which would mean they would never cross. And when you're graphing lines, you're looking to see where they cross to get the solution. So they never cross, no solution. So we call this these are inconsistent, is what we call this. Okay, so now let's talk about two lines that are just two completely different lines, but they are diagonal, and so diagonal lines are always going to eventually cross each other. So these would be intersecting lines, because nothing's the same. The slope is not the same. So intersecting lines, the y-intercept, the slopes are different, the y-intercepts are different. So they're just going to intersect at a point. That's, by the way, what you're looking for when you're graphing two lines. When you're doing a system, you're looking for where they cross. That's their solution. So that means they have a one solution, because they're going to cross at one point. So they have a one solution. And then this means they are consistent and independent. So this is what she talked about on that slide. The last one she talked about is if the lines are identical. So if you put your equations in slope-intercept form and you get two equations that are identical, then that means these are the same line, same exact line, because slopes are the same, y-intercepts are the same. That means this is an infinitely, because that means they are the same line. So all their points are the same. So they've got infinitely many solutions, or we also can say that's all real numbers. They have solutions of all real numbers. This is called consistent. This is a consistent and dependent system. So that brings us to slide 3 on this assignment. And slide 3, let me get to it. Okay, so slide 3 gives you 3 sets of equations, and they want you to classify. So you're going to do what I'm talking about here. You're going to put them in slope-intercept form, which means you need to solve them for y. You go through the steps to solve them for y. And then if their slopes are the same, but y-intercepts are different, then it's the inconsistent. If they're just two different, completely different lines, then they are consistent and independent. If the equations end up being identical, then it's consistent and dependent. So that's what you're going to do on slide 3. Okay, slide 4 is it's a system of inequalities again, and it says which graph is the solution to the system. So they give you two inequalities, and so basically on this one you're going to get two inequalities, or linear inequalities, I should say, and you're going to, I would say, graph them, because it never hurts to get you can't ever have enough practice graphing. So let's go over how we graph these. So remember, these are in slope-intercept form. So slope-intercept form, y equals mx plus b. So whatever's in front of x is your slope. By the way, the slopes, if you notice, are the same. These slopes both would be 1 or 1 over 1. That means these lines are parallel. So that would help to know that going in. Then your y-intercepts, this one's at -3, this one's at -4. So I'm going to do one at -3, 2, 3. So that's one of my lines. And then its slope is 1/1, so you can do 1 and then over 1. And then remember with inequalities, in the video they should have talked to you about how when you do your lines on your inequalities, they're not always solid lines. So this one, this first one I just graphed, it's a greater than or equal. So that means the line is included. So when I draw this graph, find my ruler. So when I draw this graph, it's a solid line. Then my next line is at 4 for my y-intercept. So I'm going to go to 4, 1, 2, 3, 4. That's my first point. Then my slope is 1/1 again. So from that point, if you didn't notice what I did here, I went from that point, I went up 1/1. That's your slope. So you're going to do the same thing here, up 1/1. Well, as you can see, these are parallel lines. They may not look perfectly parallel, but they are. Remember, I'm freehanding, so they're not going to be perfect. Okay, so then when I do, and you know what? I just messed up because this is supposed to be, that's why you have to, can't just draw that line. You have to pay attention. This is a just less than. So, let's see, I even mess it up sometimes. So, it's a dashed. That means the line is not included. So I'm going to try to draw some really dark dashes in there so you can see that it's dashed. Okay, so that's a dashed line. So that means the line is not included in the solution. So now let's do our shading. So this was our first line, and it's a greater than or equal. So that means I'm going to do purple. So that means everything is that line and greater. So we go above the line. Okay, then my dashed line that I messed up on, it is less than. So from the line, remember the line is not included, and then it's everything below. Well, then you can see what they share. They share this parallel strip. That's the solution, is any ordered pair in that strip or on that line. So now you've got it graphed. So now you go and look on your problem when you do this one. Then it's a multiple choice, which graph matches. And you've got to pay attention when you're finding the matching graph, is that, do they have a dashed line here or do they have a solid? Do they have a solid line here or do they have a dash? So make sure you're finding the correct one that matches. Okay, so that is slide 4. So slide 5 is going to be graphing again, and this time they've got it graphed. And then they want you, and what they've done is they've divided the two, and the graph makes 4 parts. And I'm just going to go ahead and show you one that I've graphed without, and it looks very similar to the one they did. But the picture's there, and if you notice the equations that they did, I already did mine, and mine was less than this line, and then it was greater than this line. So then they overlapped here. And then when I drew these lines, they made what we call quadrants. So I label them 1, 2, 3, 4, and that's what they've done in the picture. And then what you're answering, it says which region represents the solution to the system shown here. So again, they've already got the picture drawn. You just got to know, because they've just done all different colors, so you just got to know where would the shading be. And so on my picture, my shading, where the solution of the 2 lines would be in quadrant 4. So then you look at the one that they've given and you determine where would the shading be and which quadrant would they share. And that's your solution. So my answer would be quadrant 4. You're going to go to slide 5 now on the assignment, and you're going to see what their answer is, or what the answer would be for that problem. Okay, so I'm going to stop this one here because I don't want to make the videos too long. So I'm going to stop here and then I'll start another one.